Welcome, everyone. Thanks for joining us for our live demo on reliable connectivity when every second counts. I'm Scott Goldie, Product Marketing Manager here at Dejero. I'll be facilitating today's live demo. And joining us today from out on the road are my colleagues Dean Taylor, our Director of Technical Account Management, and Jason Philbrown, our Public Safety and Fleet Sales Manager. He's making a guest appearance there as our advisor and tactical driver. He's keeping his eyes on the road at all times. And just before we get started, just a few housekeeping notes for the webinar. It's going to last about 30 minutes with around 20 minutes of live video out on the road with Dean and Jason. And then we'll have plenty of time as well for questions. Recording is going to be available on dejero.com soon after the session. We'll make sure to notify everyone of that. And if you have any questions at all throughout the live demo, just use the Q&A function in Zoom, and we'll be sure to answer your questions as we go. A few key takeaways that you'll have by the end of this session is you're going to, first of all, learn about the PACE model. We'll be talking about that and how Dejero fits in. Dean will also be explaining the quality of service ladder, and he's going to describe the differences between RSSI, which is signal strength, and upload speeds. So let's bring in Dean and Jason, who, as I mentioned, are out on the road. I think somewhere around Dallas, Texas. Is that right, Dean? Where exactly are you?
Yeah, Scott, we're just passing McKinney, Texas right now. We're south on the 75. And thank you all for your time today. It's nice spending about 20 minutes with you. There will be ample time for questions. So, Scott will be monitoring that, interrupting me or pitching a question when we see it. But bottom line, we're headed towards Dallas, and we've been on the road for about 10 days now. We were at the Texas Public Safety Robotics Summit in Burnet, Texas, which is about 4 hours away from here. And as we've been working our way throughout the great state of Texas, we've been utilizing some of our connectivity testing systems. As a matter of fact, Scott, why don't you go ahead and hype up the map here for me?
Bring that up
This
here.
particular, this is our current route. And some of the measurements you're going to see on this particular map are RSSI. And you can see that as Scott switches between them, some of the RSSI values are indicators of signal strength, right? That's a signal strength between the tower and your vehicle. Much like when in my house, when my kid starts using his iPad, and then all of a sudden he's like, hey, I can't make a connection to the internet. He's got a great connection to our local Wi-Fi, but he's got no connection to the outside world. And that's why signal strength, RSSI, can be sort of a misnomer, because sometimes you can still have connectivity, great connectivity, with low signal strength. And that's what we're going to talk a little bit about today as we sort of make our way on this drive. So when we were at the Public Safety Texas Robotics Summit, one of the things that we kept hearing, and you can pin me back live, Scott, one of the things that we kept hearing is we kept hearing a lot of professionals. And again, the robotics summit is a lot of video, a lot of data, but data can be all sorts of things in your vehicles. It can be body-worn cameras. It can be in-car cameras. It can be mobile data terminals that are even more robust than what you're used to. So it's not just video; it's connectivity. And one of the takeaways that I heard, Jason, when I was at the Public Safety Summit, is I heard a lot of people talking about how the demand for that connectivity is getting bigger and bigger in the vehicle. The reason for that, in this particular case, they're talking about being able to do, I heard one guy wanted to do up to 8 streams of video out of their vehicle. So that was my takeaway. The takeaway that I had was like, okay, I need more data in this vehicle. And remember, when I'm talking about data in the vehicle, I'm talking about upload. Anybody can do a speed test in your vehicle, but an upload, your transmit out of your vehicle, that's what's most important. So that was my key takeaway. Jason, why don't you share while you're driving? What was yours?
Yeah, I mean, you hit the nail right on the head with regards to the demand for more connectivity, right? Whether we were talking to a single drone pilot or a deputy patrol officer or a chief of police or fire, they all said the same thing with regards to, man, we've got so much technology going on in our vehicles nowadays, and the demand for a bigger pipe to allow for this connectivity is even greater than it's ever been. So that's probably my biggest takeaway, is that as the demand for more technology to help their jobs be more efficient down the road happens, the connectivity levels are going to be going up. And so we need that bandwidth to increase, and that's what we can provide.
Yeah, that was kind of a good takeaway. That I think the common things. I'm doing 14 things here, so I got a webcam in here, folks. It's not as fancy as the last one where I was switching between cameras, right? So the common takeaway is that things are not decreasing in vehicles for connectivity. Things are increasing. The demands are getting higher. They're getting bigger. And if you're in public safety, whether it's fire, EMS, or law enforcement, there's a term in your ICS program, in your incident command system, there's a term called PACE, and we have a slide for it here. The PACE plan is your primary, your alternate, your contingency, and your emergency. And the reason that's important to talk about is actually in this vehicle, we're adding a Starlink Mini on a WAN blend into our device, completely seamless. And I'm calling that my emergency, right? If I have problems with every other piece of connectivity that's coming into my gateway as a WAN blend, completely seamless, gives you the same IP address as all the other sources. There's no failover. There's no unplugging stuff. There's no split traffic. It's all in the same network, right? So that's important. But PACE is going to be your primary, your alternate, your contingency, and your emergency. And why do we talk about that? Why is that important? Well, every public safety agency needs to have more than one way to get their information back to the location that they need to get it back to. The people that are rolling in, the people that are making decisions on what other assets you might need, and all of the other things that are benefiting from having that information come in. So the challenge here is in the PACE plan, in your patrol car, what is your alternate? I don't know. If you have a two SIM competitor device, maybe your alternate is your second SIM. What's your emergency? Is it your two-way radio? That means you have no data. So you have to start getting information from the communication center. Instead of running that locally, you have to use voice time. And then finally, what's your emergency? It could be nothing. It could be hand signals at that point, right? So in the case of this vehicle, and I'll show you in a little while, I'll switch cameras and we'll show you the Starlink that's just suction cup to the roof here. It should last the rest of the trip. That's our emergency. And the reason I bring the PACE plan up is because of the next slide, which is our quality of service ladder. I think that the QoS ladder is something that we talk about. And in the introduction, I said I was going to teach you a little bit about it. It's a ladder that you want to climb. And so I'm going to talk give you sort of a vector on this chart. The middle column is the most important column to me. That's your additive upload in your vehicle to do these processes. And that's not like your download, right? You can stream Netflix in your car as much as you want, but you need to transmit data out of the car. So on this particular chart, if you look at that, you're going to see that number climb and climb and climb, right? So the first step is your critical, your life safety. So the first thing we talk about is voice. And, there's a lot of people that are not using voice on the radio. In my opinion, that could be a simple CAD message to replace a radio, but it's still a very small amount of data, right? Then your next step is your CAD or your complicated AVL, right? Your automatic vehicle locator. So in a fire environment, maybe it's the ability to know where a vehicle is immediately, so you can dispatch it quickly and save a life. Then when we move throughout that ladder, the next step is that mission critical. Mission critical is things you want to do, maybe you don't have the ability to do currently. It could be your applications running on your mobile data computer. It could be telemetry. Fire agencies are measuring the amount of water in vehicles now in apparatus. They're measuring water pressure. They're doing alerts on collision avoidance. Large agencies are putting in HAWS, collision avoidance, to make sure that they don't have a traumatic or tragic event while responding to somebody else's need, right? You don't want their emergency to become your emergency, right? And then continuing up that QoS ladder, we have the interoperability, right? That's what are you going to do for all your partners coming in? Are you going to give them Wi-Fi? You're going to give them the ability to connect some of their devices so that you can keep providing an ad hoc command post, mutual aid style. And then, lastly, what we heard a lot about in the Texas Robotics Summit, which is all of the video applications, body-worn cameras, loading that body-worn camera from a dock, live in-car cameras, prisoner monitoring from a third source, your live body-worn camera as you step out of the vehicle. All of those are video applications, and they require even more connectivity in that vehicle. So that's the top of the ladder. And what I think is important is that we're trying in this conversation, Jason, to sort of, get you thinking about that ladder and, how you could climb that rung. So do you have any comments you want to make on that part?
Yeah, I mean, I think that when you're talking about where we started as a company, providing that high level of data capture and sharing that, we're actually coming down that ladder to meet the needs of our customers that are now coming up, right? So now the increase for more connectivity, including that video data, they're coming up the ladder and we're coming down to meet them. So I think we're in a very, very good spot right now to help meet these needs. And more importantly, to keep all of these different technologies connected without that failover.
Yeah, that's a good point. Something I didn't think about is that Dejero's been in business since 2008. And just put my mic there. Trying to give Jason a louder voice. So we're slapping the mic over there. Dejero's been in business since 2008. We started in the video industry. So we've been pushing video files since day one. And I think that's an important point to share with y'all. Scott, I'm gonna, pause for half a second, sort of spin the camera around here. You can see we're on the road. There's a little bit of the road there. Not a great shot, but I'm gonna let that sit for a second. Do you have any questions that have come in so far, Scott, that we could answer for you?
Yeah, for sure. I just was waiting for the right moment, but thanks for showing us that you're actually on the move there. Not that we didn't believe it, but it's
Yeah.
I'm always surprised, even though I'm a part of this and see it all the time, of how good of the quality of the video and the audio is, considering how you're moving down a highway and obviously bouncing around between towers, right? From a coverage
Yeah.
perspective.
Yeah.
So,
And Scott, we're not going downhill. I don't want to take the camera off, so I've sort of just rotated it as it
yeah,
could. So I'll
just looks
spin
like
it around
you're
eventually.
just looks like you're going
Yeah.
faster. That's all.
Yeah, exactly.
Yeah, so a couple of questions. The first one's just related to Dejero's smart blending technology. And how does that blending integrate with existing communication systems?
Yeah, great question. So I think the Starlink Mini that I have blended in as a WAN is a great example of that. The difference in our technology and others is how we're able to seamlessly blend different devices. So how does it integrate? It integrates seamlessly. If you have a Wi-Fi hotspot that you for some reason wanted to utilize, you could utilize that. We use low Earth orbit satellite. We use stationary geo satellite. We there's a couple of events that we do in areas where the public safety agencies, they actually run an Ethernet line and blend into there. And these are large mobile command vehicles, so they don't want to change all their IP structure, but they want to have their secure internet connection through their standard protocols. So instead of redoing all that, just plug the Ethernet cable in. So it blends. It adds it as another WAN connection. The little 3220, I've had up to 3 WAN connections in there. You know, we have the ability to do dongles to add more WAN connections on that. The device that we're using today, I've got several WAN connections, so I could blend in a couple of sources there. So that pretty much answers that question, I think. So
Yeah,
spin
sure.
that baby around. Thanks for bearing with me on that. I want to move on.
Yeah.
We've got 12 minutes left, so I want to make sure we get to everything. And I want to talk a little bit about RSSI. So one of the biggest questions that comes up is like, you know, you're holding your phone, and we talked about this earlier, but what do your bars show, right? So your signal strength is a immediate indication on your device on where you are and how close the tower is. And that's the indication. It's the received, as a matter of fact, RSSI, and I hope Ali's listening because I'm not 100% sure I'm getting this right, but it's received signal strength indicated, right? So it's usually in a dB format, but that's the power that's coming from that antenna and reaching your radio, right? It's not the throughput, it's not the other parts. So as we switch slide here, there's not a relationship between RSSI, signal strength, and total amount of throughput. What the relationship is in traditional environments, you've come to know that if you've got 1 bar, you know, you're not sure if you're going to have any throughput, right? So that's a challenge with the way we think about RSSI. You can have low RSSI values, and you can still have decent throughput because that could be a different frequency. It could be a higher frequency that allows more bandwidth. So you're just trickling it, right? So to base an analysis only on RSSI, it's not a good thing to do. And the reason it's not a good thing to do is kind of what we're showing here on the slides. There are ways to do this differently. Signal strength is not always the most reliable. Upload speeds matter. And currently in this drive, we're doing key performance indicators. So we're looking at upload speeds. In a little while, I'm going to have Scott pull up a chart that's following our trip right now. So let's go to the next slide, Scott, and sort of, I want to talk about why it's important that we're measuring these things. And I look upon this as a single type, whether it's a single SIM radio or the Dejero blending connectivity. There's really 3 things you're looking at there. You're looking at your throughput, which is the data transmitted and received. You're looking at your bandwidth, right? Which is where we're looking at all of those factors in bandwidth, especially upload. And that's the important part, because your pipe, if it's big, you can still have a bad RSSI, and you're going to allow enough throughput to get your needed mission done. And then finally, latency, right? And latency is, always going to be a factor. But if you're not flying a UAS through the control, I don't think that latency is as important in public safety as it might be for live television. Latency is the delay that traffic going through your pipe takes. So we can come back kind of live here, Scott, and we'll talk about our goals. Let me quickly, Jason, I know you've been listening, so let me do one thing here. Let's show you full disclosure. So I'll switch to this camera. So right in there is a little suction cup. That's a Starlink Mini. I've been watching it, and those are our antennas for our test devices. We actually do have a couple of products in here, so we're testing multiple products. And what's important about that is that the reason we test multiple products is to see what performs in different environments. So let me switch back. I'm sorry, I'll switch back. I promised you I wasn't going to do that, Scott, and yet I did it. So there we go.
It's really helpful to see the Starlink on the roof, though. It's
yeah, it's just
I'm a little
suction
nervous
cups up
about
there.
the suction cups.
Yeah. Well, we drove faster. We drove faster yesterday than we're driving today, so we're in good shape. We had it on for 4 hours, right? So the reason I bring all this up about why we measure things a little differently is because our goal is to provide some data. And on this challenge, that's what we've been doing. We've been going to areas where there is little or no connectivity, and we've seen it all. We were on dams today. We went by the dam store. We've been in Burnett, Texas, where most of the people were commenting that they couldn't get more than a bar on their cell phone, and that was at the bar down the street. So it was quite a. And now we're coming into the Metroplex, and we're seeing some really good throughput. I think the last time I took a look at the kit, I had 220 down and 61 up on our device as a blend. So that was a very good thing. I think that what we forget about is that cellular providers create a network based on their customers' needs, not public safety, because you're not the only customer. As a matter of fact, you're probably the smallest customer, right? They've got everybody else using it. So Scott, let's go to those two maps that have the drive. Hey, to be fair here, folks, this is from a drive we did earlier, and I want to just kind of show you something. We'll start with Provider X. Provider X is a well-known cellular company, and on this particular road, this program is available to everybody. It's called cellmapper.net. These are very bright green is good calls. Dark green is weak or bad calls. And red is drop calls. So you can see Provider X on this particular road. And this is a interstate highway. This is in Colorado. So it's near Gun Barrel, Colorado. So you can see that Provider X has some great connectivity there in that area. And then if you switch to Provider Y, you can see that Provider Y up to the northeast here has great connectivity up there, but you follow the road down south where Provider X was, and there's no connectivity. It was all drop calls. And then if you kind of look in the middle, there's a big red area, right? So Scott, if you sort of bounce between those a couple of times, you can see what my point is and why we measure with throughput and we look at latency we look at packet loss, we look at jitter. All of those things help us and our algorithm make a determination of where the best connection is for you. We got 4 minutes left, so Scott, you can come back live to me.
Yeah.
What any comments that you have, Jason, on what we've been talking about?
No, I think you bring up very good points about how this sort of data capture can really help our customers. We have the ability now to either loan them something for a week, or we can drive out to their trouble spots and go and capture this data to be able to present to them in person, to show them, hey, listen, we hear your concerns about no connectivity or little connectivity in these areas, and here's how our device is working. Here's all the different things that we can plug into it. Here's how we can shut off a carrier or take out a WAN and show that there's no failover or failback in that scenario.
Yeah, that's a good point. Scott, for 3 minutes before, I know we can have time for questions, but so we have time to show that map real quick, the Grafana instance.
Yeah. Bringing it up here now.
So, hey, folks, this is a work in progress. We're testing some of our technology as well, but I wanted to point out that if you look at that graph, there's some places there we're doubling back, and that's where you see the dropout. But the purple dots represent over 50 megabits outbound. So on this particular graph, we're producing a very good amount of connectivity outbound on this device. And then Scott, if you go to the rest of the chart, or you zoom out, there's a couple of things that we're doing on this chart that I think are important. We're looking at latency spikes. We're looking at other products. And then we're even looking at RSSI down at the bottom there. So these are ways that we can come back to you with an intelligent comment that's not just based on RSSI. So Scott, coming back to us, any questions for me or Jason? Because I realized now that Jason had the clock set for 30 minutes. So we got 2 minutes left for questions.
Yeah, it's all good. Just one quick one around if the webinar is going to be available after, which I can cover. Yes, we'll be sending out an email afterwards when it's available. You'll be able to see it on Dejero.com. And then another one just around data protection from like a customer's perspective. How is our data protected? What sort of security measures are used to protect that data?
Oh, great question. Jason, you want to jump on that one?
To talk about
Okay.
the newest.
Okay. So Dejero is going through a very, very laborious process called FedRAMP. And, we're here in the great state of Texas. They were talking about TexRAMP, right? Which is the state version. It's a security protocol that has all of the recognized requirements in it. And we're counting down here. We are going to be FedRAMP moderate compliant. We're sponsored by DHS. Oh, big bush in the road here, but my tactical driver is avoiding it. So thank you. So we're going to be FedRAMP moderate, which means that your data is not only secure at our level, but it's secured at a recognized standard. And what I'm hearing from most people is the minute you open your mouth and say FedRAMP, the 1,300 question questionnaire, wow, that guy did a good job avoiding that, goes away. So we're going to be FedRAMP moderate here shortly. So hopefully that answers that question.
Yeah, for sure.
What else you got for me?
Nothing else so far, but if anybody does have any questions, we don't mind staying on for a few extra seconds here. But yeah, it was great job explaining all this stuff while you're on the move. Jason kept you safe.
Yeah, he's a good driver. I'll keep him around. He successfully avoided looked like a limb from a tree. Oh, there's our
Tactical
time.
driver is a real thing.
Yeah, there's our time. Hey, I'll stay on for a few minutes to answer any questions that there are. We do want to be respectful of your time. I want to thank you all for being on the call today, on the road with us. I do have a question, Scott. How did we look? Watch yourself.
Great. The sun was shining on you. You had this
Yeah,
nice like halo effect around you the whole time. It's
yeah,
it looked good, but it was like clear audio and video. Like I said, it's always surprises me when you're on the move and can get that kind of quality throughout. So it worked
gotcha.
out really well. But
Well, I see there's still 19 participants hanging on. So is there a question from any of
yeah,
them or are we,
one just
okay.
came in here around Starlink and what the impact of the Starlink Mini is, like the upload and what's the upload or download of that.
Okay. Yeah, I said that earlier in the call. So the Starlink Mini is a very small form factor. And so what your expectation is, no matter how you use the Starlink Mini, is remember the smaller the antenna, the less power you're going to send towards those satellites, right? So what I've heard talking to all the teams that are using either Starlinks or Starlink Minis in conjunction with other devices, like we've got teams that are blending it in ours. It all seems pretty consistent on the Mini, which is I'm hearing about 10 megabits up. But interestingly here, we're driving, we're mobile, we've got it flat. So we're not spending any time orienting or looking a certain way. So I've experienced like 6, 5, but remember, if you're in an emergency environment, 5 is a healthy upload. 5 is definitely a healthy upload. But again, it's blending seamlessly into the device, and we're not even aware that it's kicking in. If I could go look at the data, but I don't think it's kicked in once. So
Yeah, that's great. That's very helpful information. We don't have any other questions, so I think we're safe to wrap up. Appreciate everyone's time for joining us today, and Dean and Jason, thanks for taking us out on the road with you, showing us the insights here from your time out there working hard on the road. So with
uh,
that, thanks everyone. Like I said, the session will be available soon on Dejero.com, and we'll be sure to email and let you know when that's available. And have a great rest of your day. Take care, guys. Stay safe.